Okay, sorry, we're just going to try to finish this up here. So we know that there is the 000 at 0 here. We knew that it's going to start here on this side and it'll end down here on this side. So we know that this is going to look something like this. Like a cubic because it's a 000. And then at 9/2, which is about 3 and a bit, 4.5. So you're going to be somewhere here. This is going to be at 4.5 basically. And that is going to be a double. So if it goes this way, it's going to curve back up. And a double means it's going to bounce off of that 0 and then go towards the end like that. Whereas this one's going to go towards that way. Okay? So don't forget to make it like a cubic at this x = 0. Oops, something disappeared. And then at the 00, it's going to be like a quadratic, so it's going to bounce off the x-axis. Okay? But wait, we didn't check. We forgot our third feature, which is the y-intercept. And I know based on that, that's going to end up being 0, but just double check. And we've got y = -4, bracket 0, 2 times 0 minus 9 squared. Well, this 0 is going to make everything equal to 0. So y = 0. So yes, the y-intercept was 0. Okay, we just double check. Alrighty, now ready for a challenge? Well, if I gave you the graph, can you come up with the equation? So now we have to think about all those features we talked about, those 3 things. Let's look at the end behavior. So the end behavior is going to help you with the degree and the leading coefficient. It's going to help you determine what are those going to be in your equation. Well, the end behavior, this end behavior is a negative infinity, goes into a negative infinity. So because these are the same, we know it's going to be an even degree. And because it's in the negative, we know the leading coefficient is going to be a negative, right? Because normally otherwise an even degree would normally go upwards into the positive infinity. What else can we say? Well, now we've learned about the idea of looking at the x-intercepts, and we can interpret them based on the type and the number of x-intercepts. Okay, so how many x-intercepts do we have? Well, I see one here, and I see another one here. This one, you can tell, is a double 0, right? The reason I can tell is because the graph bounces off of that x-intercept, okay, like a parabola. So we know that's a double. And this happens at the origin. So we know that the x-intercept would be x = 0. Okay, so that can happen when there's an x minus 0 squared, because it's a double. So a double would therefore mean that the exponent's got to be a 2 on it. Another way of showing this could just be an x squared if you wanted to. Okay, simplify that more. The other one here, this x-intercept, looks interesting. It almost looks like a double because it goes from one end and it bounces back out. But look how much flatter this is. Do you recall why it could be flatter? Well, that means that it's a higher degree, but it's still even. Like a double, but it's higher. So think of a quadruple. Quadruple or a quartic type of thing, right? So it's quadruple. So we call this a quadruple 0. Okay, like x to the exponent of 4. And this happens at the value of x = 2. So that means that's going to be x minus 2 all to the exponent of 4. So that's going to help us come up with our equation, which we can assume right now is y equals, there's going to be this x squared, and there's going to be the x minus 2 to the exponent of 4. But the one thing that we don't have is the value of a, and we cannot assume what that value is. We can definitely have trouble figuring out from this polynomial what that is intuitively. So you have to solve for it. How do we solve for an a value in any type of function, we find a point. So let's find a point here. Why don't I use this point right here? There's a point here at, if I look at the scale, that's 1 for x. And down here, this is going by 1, so that would be -2. So 1, -2 is a point on the graph that's not one of these x-intercept points. So I'll use that as my x and my y. So I have -2 is equal to a bracket 1 squared, 1 minus 2 to the power of 4. So -2 equals, this is just 1a. This is going to be -1 to the power of 4. So this is -a equals -2. So a is equal to, oh no, that's even. So that's positive a. So a is equal to -2, which makes sense because we said that the leading coefficient has to be negative. So therefore, this equation is y equals -2 x to the squared bracket x minus 2 to the exponent of 4. And that is our function. All right? So now we have a better way, now that we've known the end behavior as a polynomial and the short run behavior of polynomials in terms of the zeros or x-intercepts, we can now have better understanding of how to draw and come up with our equations. So review all these notes and try out the homework. Good luck.